We should start off by saying that if anyone has any questions to submit to the Passivhaus panel, and I'll be introducing the panelists shortly, to use the Q&A function or the chat function that are at the bottom of the Zoom webinar function, and you could submit them in. We have staff that will go through and then provide questions up to us directly so that we can then dazzle you with our responses. So with that being said, good morning, everyone. My name is Giovanni Cautillo. I'm the president of the OGCA, and I have the delight of introducing you to an illustrious panel. We're going to be talking about Passivhaus 101 right now. And the OGCA has linked up with Passivhaus Canada through the, what is it again? The Canadian Building, or was it Canadian Green Building Council. And it's just, in order to provide our members with information that is timely and kind of the direction that the government and the industry is moving in. So obviously the webinar represents, I think this is our 8th or 9th in the series of OGCA webinars, but our second in regards to innovation. So this is wonderful to have these panelists involved. I had to talk about one of the world's, leading design and build standards, which is Passivhaus. So a lot of you are going to ask, but isn't Passivhaus just a residential directive to go to? And ultimately, you're going to find out through the discussions today that there are other certifications and standards that it's built from. It's not solely residential. It's the name. It's a brand, right? It's not but it's not a construction concept. So it's going to be very, very interesting to discuss this as we go through. And Passivhaus is, I guess, the residence experts when it comes down to it. And it stemmed from single family homes, but it's quickly gone into multifamily apartment buildings, offices, and clearly on the ICI realm into skyscrapers and whatnot. So I think I would like to take this opportunity to introduce our panelists. Now, if I went through their full bios, it would take me the entire session to do. So I'm going to take a very short excerpt of each one of them. We're going to start off with Chris Ballard. Now, Chris has a history of supporting environmental and land use causes, most recently as the Ontario Minister of Environment and Climate Change, implementing the government's plan for a clean environment and a sustainable economy. He also served as Minister of Housing and the Minister responsible for Ontario's poverty reduction strategy and member of the Treasury Board. So Chris has been incredibly busy. On top of that, Chris is a past executive director for the 60,000 member Consumers Association of Canada, clearly based out of Ontario, and a founding board member of the Consumers Council of Canada. His leadership in journalism, communications, and public affairs includes terms as president and board member of the Public Affairs Association of Canada. So like I said, that's just one paragraph of his bio. If I went on and on and on, we'd be here all day. Right after Chris, we'll have a second presenter, which is Deborah Brian. And Deborah is a COO of Kearns Mancini Architects. She has a degree in structural engineering with over 18 years of extensive experience working in the architecture and planning, real estate, and construction industry. Deborah has been at the forefront of Passivhaus conversations as a board member, designer, peer reviewer, trainer, speaker, policy change advocate, and writer on all topics related to Passivhaus design and construction. So to say that she's a walking encyclopedia of Passivhaus is kind of an understatement. She's a founding member of Passivhaus Canada, Ontario Passivhaus Group, and the Passivhaus Association in Ireland. Deborah has designed many innovative building envelope solutions for large-scale Passivhaus developments and has brought forward high-performance building innovation in the construction industry. And I very much look forward to her part of the presentation. Now, rounding out our panel, we have a gentleman that is well known to the OGCA and has been a member of the OGCA for quite some time. Henry Schilthuis. This is a name that it sounds like a Spartacus. It sounds like a gladiator in the rings at the Colosseum. But Schilthuis Construction has been around since 2003, a family-run business in operation since 1952. And Schilthuis is a proud OGCA member and a leader in design build projects, offering project management and general contracting services. Their team is one of Ontario's most experienced construction teams, specializing in multi-unit residential, commercial, and institutional passive house projects. Hence why Henry is here. And he's going to bring a wealth of knowledge and enlighten us all in this particular webinar session. So with that being said, I'm going to pass this along to Chris as our first presenter. Chris, would you take it away, please?
Absolutely, and thank you, Giovanni, once again for bringing Passivhaus Canada into the fold so that we can present today. You know, I know folks don't really want to hear from as much from me as they do from people in the field. So that's Deb and Henry. So I'll be as quick as I can be, and then I'll pass things over to Deb, and Deb can pass things over to Henry. Looking forward to some really good questions towards the end. So we hope we can provide some stimulating conversation today. So let's move the slide along to the next slide. Great, thanks. And we'll keep going. Next. Our intro, I've said, already talked about how we're going to move through today. So next slide, please. So who is Passivhaus Canada? What is Passivhaus Canada? We're a membership-based social enterprise. We do a lot of advocacy work. We provide a lot of education and professional development services for the building industry. We provide technical services to our members, to component manufacturers. And we have members, staff, and instructors all across Canada. And here are some faces from our most recent graduating class. Next slide. Our mission, really 3 points. We want to make zero emission buildings known and adopted by government, industry, and the public, and that is really accelerating. We support government and industry in the transition to high performance buildings through education, certification, and policy development. And we promote the Passivhaus Institute building standard, which is globally recognized as the best building standard for high performance buildings. It's recognized by institutions like the EU, like the United Nations, and more municipalities across Canada. Next slide. So a bit of policy context for today, and I know this is the Ontario General Contractors Association, so the sun doesn't rise and set just on Toronto, but I wanted to talk a little bit about the Toronto Green Standard version 4, which was just approved by Toronto Council last week with barely any discussion. It's one of the most critical and high impact pathways to Toronto's net zero objectives. And you know, if this was 5 years ago, there would have been ongoing debate about whether or not Toronto's going too far, not far enough, how fast. But Toronto seems to understands that to get to their net zero targets, that buildings and building better is a critical part of that. It's a leading standard in North America now for a variety of reasons, and it's leading. The City of Toronto is leading by example, requiring all city-owned buildings to be designed to net zero emissions starting in 2022. Not only that. Organizations like Toronto Community Housing Corporation are using PHI's Interfit standard to retrofit about 200 towers over the next few years. Absolutely massive multi-billion-dollar project, retrofitting old towers that need to be updated. So Passivhaus just isn't about new buildings, it's about existing buildings. More on that later. Next slide. So what caught my attention last week, maybe yours as well, a number of headlines where the European Union said that it would be imposing carbon tariffs on those on imports from those nations that didn't have aggressive carbon neutral policies in place and weren't actively pursuing them. The same day that the EU came out with its policy, the Federal government in the United States released its multi-trillion-dollar infrastructure plan that also included the possibility of carbon tariffs on imports from countries that don't have an aggressive carbon neutral policies in place. What does this mean for Canada? Well, quite frankly, what it means is that if we don't get our act together and have those carbon neutral policies in place, that very likely the United States and EU could use their policies to block imports of our products. And Canada relying so much on exports to these nations puts us in a bit of a precarious position. So it's one of the reasons that federal and provincial governments have been scrambling to beef up their carbon neutral policies, is so that the wealth of our nation, which depends on solid exports, won't be damaged if the EU and if the United States get serious about carbon tariffs. So always in the back of our heads is this higher level issue. Your organization, some of you are international organizations that build international. Some might be smaller, but we're all focused on Canada being a wealthy nation, and our exports are very important. We can't have those curtailed because we don't have the right carbon neutral policies in place. Hence, we see what Toronto is doing in many municipalities across the country. Next slide. A few reactions to the Toronto Green Standard from the Atmospheric Fund and from Mayor John Tory. What's interesting is who would have thought a month ago that the phrase heat dome would have entered our vocabulary, our shared vocabulary, but it's here. And now with every significant weather event, which seems to be happening on a daily, if not weekly basis across Canada and certainly the world, the question that's asked is this weather the result of climate change? It's hard to tie specific weather events directly to climate change, but the meteorologists, the climatologists, the scientists who study this stuff tell us that yes, we have changing weather patterns that are directly related to climate change, and that weather will become more extreme. We will be wetter or hotter depending on where we live in Canada. So Toronto's addressing this. We have over 500 municipalities across Canada that have declared climate emergencies. Next slide, please, with that in mind. So Passivhaus, and I won't get into sort of the technical aspects of Passivhaus because Deb is going to take some time to do that. But I just wanted to give you a sense that there are a number of certifications for Passivhaus. We have Classic, Plus, and Premium. We have low energy buildings. So if for whatever reason a building can't make it to the Classic standard, low energy is great too. And then we have a very rigorous Interfit standard. That's a deep energy retrofit that also focuses on health and comfort. The Passivhaus new build can create a building that uses about 90% less energy than a code-built building. If you go the Interfit route, we're looking at 75% less energy than the building used previously, all for a very small cost premium that's easily recouped. Next slide. Next slide. So wanted to show you some pictures of sorts of things that Passivhaus is up to these days. And as Giovanni mentioned at the outset, Passivhaus is, I'll say, an unfortunate translation, perhaps, of the German Passivhaus, H-A-U-S, meaning building. Passivhaus is certainly more than houses. It's tall structures. It's community centers. It's single-family residence. It's MURBs. Basically, whatever built form you're looking for. And it's one of the reasons that architects particularly like Passivhaus is that it gives them the flexibility to design the look and the features that they think are required. Next slide. So this one is something happening in Vancouver. A couple of more towers that are going up in Vancouver as well, tall towers that will be Passivhaus, 650,000 square feet for these two. These are well underway, by the way, in terms of approvals and design. Next slide. Right here in Ontario, this is the Humber College campus. And this is an Interfit project where they took one of their older buildings and interfitted it to be much less energy intensive. In fact, this building has solar panels on the roof that feed into the local college grid. It produces more electricity than it actually uses. So kind of a neat space. And when I toured it last pre-COVID, it was filled with instructors who were telling me that it was such a wonderful change from the previous design of the building, which was hot in summer and cold in winter, and folks were enjoying comfortable and healthy air and thermal comfort. Next slide. Here we have the Ken Sobel Tower in Hamilton, Ontario, and I'll say that Hamilton really is in many ways leading the way. Passivhaus Canada started in Vancouver. There were Passivhaus chapters across the country that came together to form Passivhaus Canada. Our headquarters is in Vancouver, in Victoria. BC has been seen to be the leader in Passivhaus construction over the years, but slowly and now quickly, Ontario has been overtaking BC in many ways, including the Ken Sobel Towers, which I believe still is the largest Interfit project, certainly in North America, perhaps the one of the largest, we'll say, in the world. And there's lots happening in the Hamilton area with not just single family residences, but MURBs, a lot of it led by City Housing Hamilton. Next slide. So I mentioned early that we do a lot of education, and we find it's one of the most effective ways to help industry, to help the building industry prepare for the market transformation that is underway. The world is changing all around us, and businesses sometimes look for ways to engage in that transformation. So this is just a sampling of the types of classes we offer, courses we offer to ease that transition. So whether you're an architect, an engineer, a general contractor, a tradesperson, a government policy person, there's a level of course, there's a level of work that will help ease the transformation into this new world that we're in right now. Next slide. We're getting near the end. Oh, I wanted to tell you, especially speaking of Interfit, I wanted to tell you about our Tower Retrofit Symposium, September 22nd, 23rd. It will be online, and we're bringing together folks from all across the country to talk about retrofitting, deep energy retrofits to towers. This is a little snippet of Ken Sobel here, tower from Hamilton. So we're partnering with the Tower Renewal Project. You know, it's estimated there are 10,000 towers across Canada that are in desperate need of renovation, mechanical windows, facade. And now's the time to go deeper and do that deep energy retrofit. So we're working with government, we're working with financial institutions to try and make it easier to interfit these 10,000 buildings across the country. And as general contractors, we felt you'd be interested in learning more about what I think is a fantastic business opportunity in the years ahead. Certainly government has woken up to the fact that they will not meet their climate change targets, their GHG emission reduction targets, unless they include deep energy retrofits to big buildings, not just homes, but these towers. So we've got the ear of government now, and I think it's contingent upon all of us to continue to push the deep energy retrofit of towers song. Next slide. I think we're getting to the end. Yes, thank you. More information about our organization, passivhauscanada.com, and feel free to reach out, and happy to talk to any of you about Passivhaus and what we have to offer. So I'm going to step aside now and pass the baton to Deborah from KMI. Take it away, Deborah.
Thanks, Chris. Just give me one moment there too.
So while Deborah prepares everything on her slide deck and her presentation, Chris, I have a question. Just overall, I'm assuming that, you know, in order to get Passivhaus, you know, the standard up and running and whatnot, you've got to get buy-in by owners. It's, you know, it's not necessarily, you know, the contractors pushing the, you know, we could suggest it, but this is something that really happens at the owner's level, does it not?
It starts all up and down the value chain, we'll say. Yes, owners, yes, government incentives, yes, Passivhaus being there with technical support and educational support, but we need the entire chain, the entire building industry chain to be up to speed with Passivhaus. So if an architect says to an owner, let me tell you about a low energy option, the owner knows what they're talking about. And the same with the banker, and the same with the GC. So we're talking to everybody, because everybody is important. It's not good enough if the owner, just the owner, knows about Passivhaus, and yet they don't have a design team that knows anything about it. So everybody needs to buy into a different way, not a radically different way, but a different way of constructing. But ultimately, you know, the decision to move forward is the owners and those who are financing the owner.
Excellent. Thank you for that, Chris. Now, in regards to architects, we have, you know, Deborah here, who is going to astound us. So Deborah, take it away.
Thanks, Giovanni. I guess a lot of you are already working in the industry, and you hear the terms that are thrown around quite frequently: high performance buildings. And what are they? So I think Passivhaus can be confusing for people, again, because, you know, the term house, and it doesn't really explain itself too well. But just from a high performance perspective, what is it? It's, you know, low energy consumption. What does that mean for, you know, what does high performance building mean for you? Is it low energy consumption, durability, overall life cycle performance? You know, excellent lighting control, comfort. What is it that you would be interested in when you consider high performance buildings? And so just to tie that back to Passivhaus addresses the high performance building expectation by addressing all of what most people would think should be in a building. And it covers health, comfort, environment, and significantly reduces costs. The interesting thing about Passivhaus was actually born out of the need to create healthy, comfortable buildings. And the environmental and the energy savings are, by the way, a benefit of Passivhaus. And in this COVID environment we're in, I think people are more concerned about health. And so the Passivhaus, because it addresses building physics and biophysics, it provides a building that is healthy to live in. And its particular focus with regards to, say, reducing transmission for the likes of COVID is the fact that the ventilation system allows for clean air transmission. We're not mixing air, it's always fresh air, fresh, clean, filtered air. And then we address relative humidity, which is obviously a reason why germs and bugs get transmitted normally in buildings. So they're just things that, you know, we get out of a Passivhaus that goes beyond one of those other types of high performance buildings that people may be used to doing, that have certificates and you're ticking off a checklist. This isn't a checklist. This is more a holistic, balanced approach to design. Sorry, my page is slow moving. The other thing that Passivhaus provides, and is quite often spoken about, is resiliency. And this is even more of a, I guess, concern, or, you know, it's something that is more prevalent today when we have the significant increases in temperature noted in BC and in Southern Ontario. That two things that people remark on their passive houses. One is if there's power shortages, that they're fine, comfortable and safe in their passive houses, but also that the smoke is controlled. The air is fresh, still coming into the building, even though there may be dense smoke outside. And then obviously with the robustness of a passive house, because it's energy resilient, I guess, it doesn't require that much energy should a building lose energy for any reason during a power outage or an energy crisis or whatever. The people remain safe inside in the building. So if it's excessive temperatures outside, it can maintain its temperature for days, possibly weeks on end, and similarly in the winter. And so passive house is a combined use of energy, efficiency, comfort, air quality. It has a quieter environment, reduces energy costs, provides a healthy atmosphere, and resilient. Sorry, I don't know if it's me, the pressing the buttons, or is it just slow to turn the page? Okay. So this came about as a conversation actually with Giovanni, because I think in the industry there could be a lot of misconceptions. I know even in Europe, even though it's used more often there's still some misconceptions about what passive house is and isn't. And usually we talk about what is put in the building, but I think from speaking with Giovanni, it was more a case of, how a passive house would affect designers and builders and whatnot. And it's interesting that initially when I thought of it, and I thought it was only like 3 or 4 remarkable things that are different. And then the list actually went on. So you'll have to forgive me, this is over 3 slides. And I'm not going to go through the has-nots, just assume the has-nots is the opposite of the is. And you can read it as I speak. It's just quicker for everybody. And so Passive House is an original Canadian idea, and so it's not German. It can be any building. It's simple, low-tech, typical it's typical HVAC. It can have typical HVAC, sorry, excuse me. It's high-quality design and construction. Yeah. So it's rigorous. So it's rigorous in design and it's rigorous in its construction. We use it's durable and low maintenance. It's climate resilient. It has super low energy and operating costs. It has comfortable temperature all the time. So it has a constant temperature, usually around set at 20 degrees. It has a healthy environment because of that constant temperature and constant fresh air. It is COVID resilient. And it is equitable, affordable, designed using science, installed by conscientious trades and contractors. So I wanted to say this because people might say, well, you're assuming on the other buildings we're not conscientious. I think in the greater scheme of things, we find that often contractors aren't actually given the time or the fees to be able to be conscientious. And so I think the passive house, when we start, there's the expectation and the demand that in the design that the contractors be allowed to be conscientious in their addressing of the installations. A design that is designed and built in collaboration, so a complete holistic design. And the owner, designer, and contractor pride. And I think often contractors and even designers often lose their way in the design of projects because we're often forced into designing solutions that may not have been the best for the building because of a budget or a design conflict that wasn't thought out of at the beginning, that we ended up having to design out in the not the most practical or aesthetical way. So it loses, sometimes it loses the end of the project. The pride is somewhat lost in it, the end result. And so Passive House is, really a list of 7 main things. So it's super insulated. So for those that are au fait with their U values or their R values, it's R effective 38. And this climate, I mean cool temperate, say for Toronto. If we were in Northern Ontario, it might be actually up to an R50. it has a tighter envelope, so our air tightness would be a 0.6 air changes an hour. So that's really, really, you know, we're talking very, very tiny hole in an air barrier of the complete building. So if you're talking a large scale building, say, you know, 100,000 square feet, you might only be talking a total of less than 6 inches round of a hole. So if you think of all of the penetrations that you allow in a building and all the connections that are in a building, you know, there really can be no leakage. So that's it's super, super airtight. Triple glazed windows, which is unusual in the market. It's something that now that we've done a few more passive houses, and you know there are more people doing them, they're more easily available. But just conversely, in Europe, it's actually more expensive there to buy double glaze than it is to buy triple glaze. So we need to find ourselves in that position there where we're creating the market for better products. And also, why should we be shipping from Europe? We can make this stuff here. So this is something that, you know, our contractors and manufacturers can be providing and offering to the market. Energy ventilation and heat recovery. So obviously, if we make a super, super airtight building, we want to get fresh air in the building. But also with that fresh air, we want to retain the heat or cool that's already in the building. So that would mean that we would have a system that actually transfers that heat. So the fresh air coming in, the heat gets swapped with the air coming in, so that we don't lose the heat that is in the air, the dirty air that's on the way out. This helps obviously us reach the targets. If anyone has ever noted that people say that passive house is up to 90% better or up to 90% less energy, heating energy than a conventional building, it's because we don't need to add additional heat on most days. The passive house is designed to be self-heating and self-cooling, and we're providing heating and cooling for backup and peak loads only. Thermal bridge free and compact design. These are ideals. Often we can't avoid these, but we have to design a way around them. And if we do have a thermal bridge, we have to make sure that it doesn't create a significant impact in the building, that it will create a temperature surface difference, a difference in temperature on the surface. Because that is what brings in mold and condensation. So this goes back to that whole healthy story. The reason it is a healthy building is we will remove all issues that would be in a building that could cause health issues. So the ventilation system keeps the air clean and keeps out all of the toxins and whatnot in the air. And the thermal bridge free design and the massively insulated envelope make sure that the building is free of mold and condensation. And then optimal building orientation is obviously an ideal. But the bigger scale buildings, this is less of an issue. It's more of a smaller building issue because we're more reliant on the free free heat from sun at that point. And then ideally, a passive house trained and detail oriented team. Sometimes you can start a project with a raw team and everybody learns as you go, but it's a little bit more difficult that way. So it is ideal to have a trained team. And then just to show differences between what we're used to. So when we say there's differences, the material is the same. What we're using is the same materials that's in the Canadian market. It's just how it's maybe positioned on the envelope, layering, the position of the layers, and how well it's installed. And go back to my original list of the differences between standard construction and passive house construction and the trained team. You know, how many of you put the lowest paid labor on site doing insulation and airtightness? Because for a passive house, these are the most important people on site. And, you know, typically we're putting the lowest paid trade to install these very important materials. And so then this is just the air tightness. So the idea is that you install an air barrier that is completely continuous and has no gaps. And then the triple glaze units. So this is just, you know, cross section of a triple glaze unit and the installed value. So what's important about a triple glaze window is that it itself is like a mini passive house. It's airtight, it's thermally broken, it has insulated values that are higher than anything typical in the Canadian market. And what's most noticeable is when we say that no surface temperature will be less than 17 degrees, try standing beside your passive house windows when it's minus 25 outside and put your hand on the surface of the glass, and the surface of the glass will be at least 17 degrees. And then this is the theory behind the mechanical ventilation heat recovery. So it is a fresh air in, which could be cool or warm. There would be a summer bypass if the air coming in is too hot. The air going out is warmed or cooled already, but is dirty. So you get rid of all the toxins and you bring in fresh air and you warm the fresh air on the way in. And there's a whole bunch of things that it does by doing that. So, the warm, stale air from outside, the moisture, odors, allergens, VOC, CO2, and carbon monoxide are all removed from the air on the way into the building. And this is actually a certified component, commercial size energy recovery ventilation unit. Some of you may know these terms, heat recovery and energy recovery ventilation. The difference is that the energy recovery also addresses the energy within the humidity. So the humidity itself is, it's hot, damp air. So we're using that to recover energy, and it will have an enthalpy wheel inside of it as opposed to the heat recovery unit. And this is just an example of one of our thermal bridge free designs. Just because it was fairly complex, we went out of our way to make sure the insulation was completely continuous, but structure loves getting in the way. And so this was just to show that in this scenario, we have, this is a bedroom on the interior, and this is structure that our core slab manufacturer couldn't make any smaller for us. So it was quite an intensive structure, and we needed to counteract the cold that was coming in from here into the building. And so as you can see that our continuous insulation that we did, we wrapped around the beam and all the way around the core slab, the hollow core slab, actually helped us maintain that 17 degrees. And obviously in a bedroom, that's really, really important. So these are the level of details we go to. And so as I said, the materials are not different. It's just how we're approaching them and how we're installing them. And the reasons why we're doing it is to maintain that health and comfort. This is ideal. Like I said, you don't often get a huge amount of control over this, especially in built-up areas, but these are ideals to start off with to achieve that energy balance that you're looking for. And so, if you can get the volume to floor ratio of your building in the ideal world, in the ideal size, then the design starts to get a lot easier. And then obviously orientation, we have ideal orientations. East-wests are most difficult to deal with because of the hot setting sun on the west. Depending on the scale and size of the building and the use of those rooms on those orientations, we can deal with those. I'm trying not to take too long. And obviously, Chris already mentioned the training, so Passivhaus Canada can provide training. But our ideal scenario is a Passivhaus consultant and designer on the design team side and Passivhaus tradespeople on the construction side. And I like to say that, how do we do this? How do we successfully build a Passivhaus? Really, it's the 3 C's: coordinate, control, and check. If we're all working with the goal to meet the Passivhaus, the rigorous requirements, to meet the 90% energy efficient, to meet the health and comfort requirements, to meet the air test, to get a better air test than any other building in the province, in the country, we all have to work together, and that's and so it's coordinating, controlling, and checking constantly. I had come up with lots of C's, and suddenly I had 10 C's, and I just said, we'll stick with the 3: coordinate, control, check. But our big thing is, how do we actually do this? Because often We like to work with our trades, but how do we get to work with our trades? And so procurement is a big issue, and this is where we started to look at, our client for them to allow us to procure.
Okay, so I'm not sure if Deborah's frozen. Maybe she doesn't have a continuous air barrier in her house. It's not 17 degrees. So based on the fact that she is frozen, we're going to kind of shift gears right now. And I don't know if she's going to come back on again, but from the contractor standpoint, I do know that we are interested in hearing from one of our own. And Henry, you've got extensive knowledge on passive house and building up to a passive house level. We'd love to hear your insight on the passive house. What it's like for you on your side of the fence. But I do want to note that Deborah did note something about the need for allowing time and budget for contractors to be able to properly do the job. So, Henry, could you just enlighten us a little bit on that aspect?
Yeah, sure. Thanks, Giovanni. Great to be here today. I just want to start off by saying, Chris also mentioned about the government's input and being on board for a passive house. It was a great day yesterday. As you know, Prime Minister Justin Trudeau is kind of on a bandwagon doing a bit of political stuff, but the announcements on Monday in Brampton on affordable housing and yesterday in Hamilton. Yesterday's announcement was an energy initiative of $5 million geared toward projects that are using initiatives like Passive House. So it was a great day for us. 5 projects in the greater Hamilton area that are benefiting from that. You also mentioned time and effort. We feel as a contractor, and I'll touch base on the conventional construction to Passive House. It's a bit more with construction management that we're using, almost to the point of an IPD, where it is essential that we get in with the owner and the client from the beginning, talk about the plus and minuses of being energy efficient, especially with Passive House, and being on board. And I think that's essential, because some of the Passive House details lead to extensive details of insulation, a bit more time. Also doing the air tightness test, where you don't basically put your building envelope until you've got your full insulated building ready for an air test. So I'm going to start on that today. Just a journey from conventional construction to Passive House, the challenges we've faced along the way. The result, highly efficient, comfortable, affordable, multi-unit residential building. Even though we are working on our 9th building, 2 of them actually will be church buildings. One will be a retrofit, the other one was brand new. We're looking also at a 6-story office. So it's gone from not only the housing, residential, to multi-res, but to others also. The lessons learned during design construction, I think, are important for us. So we'll get into that. Here, we've been around for a while, a family company. First was 2016, our first experience with Passive House. And that was on the initiative of an owner and client saying, we'd like to build some affordable housing. We want to make sure that we're spending our capital expenditure for a longer lasting building. But if we can reduce our operating costs on the energy side, what methods? And we looked at that, came up with a solution to go Passive House. And like I said, for that client, we are doing our 6th building next year. We have multiple trained people, superintendents, project managers, Passive House consultant, also a trade person. And just the experience itself has led us to many of our typical designs and how to move forward with clients. In our typical planning, we look at concept and design and build, where the owner and designer will get together. The contractor is usually the last one on board through a tender process. We like to be in early, and the city of Hamilton had just recently, through procurement and city housing, done a couple of these. where they have ventured into construction management, based the procurement on a point system. And it's a little bit different where we are involved. The last one we were awarded was last week with actually Kearns Mancini, and just dealing with what it means to be, you know, right from the beginning with the designers and with the client. The planning process that we have there, you can see that the cost, resiliency, and the final use. Yeah, because of the scale of the project where we have multiple units, especially for affordable housing, the cost that we multiply for each of these units is important. I mean, you're building a building with 400 to 500 square feet units, but you have kitchens and washrooms and everything in that scale. So we really have to be aware of the fact of cost effectiveness on a multi-unit residential building. Resiliency, we want to make sure that these buildings last a longer time than most buildings, and therefore the Passivhaus standards really give, you know, credence to quality design and details, but also products. And the final use, the Passivhaus model, in many ways, unlike a single family home, but you know, you have tenants that have different needs for heating and cooling, and we just want to make sure that we keep the tenants, the end user, in mind in all our design of that. So here we have Passivhaus versus conventional that we usually see, a lot more attention to details. The other one, sequencing. It's important that you have the tradespeople, but also your site super and project manager. The sequencing is very important, as you'll see in a couple of slides that I'm going to show up. The materials, as Deborah mentioned, some of the Passivhaus windows were basically European, and that presented challenges, especially with, COVID. Part of that was getting the windows from across being shipped over, delays on that. And we are seeing more manufacturers leaning toward more energy efficient triple glazed windows. And we have some manufacturers now in Canada getting those materials. But same with precision, as Deborah alluded to, you need quality trained people. So we do a training program for all the trades on site, not only our own personnel, but also for the trades that are engaged as subcontractors, just to make sure that they all realize the importance of the work that they're doing and how important every detail is. And cost, I'll refer to cost in one of my last slides. There is a bit of cost implication, but overall, it's not as great as we think. It could be anywhere from 4 to 10%. The analysis we did on our first project was a 4% cost, but that is more than made up in energy efficiency in the building itself. So this is one of our typical details. We did a raft slab construction for the one here, where we have the perminator, which is kind of the vapor barrier underneath the footings. These are piers that are for the main structural components. And once we pour the actual slab here, you'll see that we tape all the perminator back onto the concrete. We insulate so it's under the footings and up the sides. And once those details are there, it's care in making sure that everything is sealed properly. Go back one, Josie. There you see the actual raft slab. So it's a major undertaking to make sure that the perminator is there. Some of the initial details, and that's where changes are made as we construct this. It called for the perminator to be on top of the insulation. But knowing that the process you see there, we have a rebar mat in there. And typically when you use a vapor barrier, there is a lot of traffic on it. We're worried about puncture. So we use the concept here that we use in arena retrofits too, is that you put the vapor barrier in some cases between the 2 layers of insulation to protect it. And that way we could install the rebar mat on top of it. And you see us there pouring the raft slab. The case for the raft slab in this project was we had contaminated groundwater. We could not go any deeper. Even so, it just meant economically, we needed a full basement. So we ended up with a raft slab for this project here. So exterior insulation is a big factor on all Passivhaus. Some of the first projects we did, we went from a spray foam insulation to this one. It was an exterior mineral wool. And basically, in a lot of these projects, we are finding with the thermal breaks and everything else, using the 6-inch or sometimes depending on which method we're using, 5 or 6 or 7. We are having the exterior mineral wool on the exterior. After you see the building there is blue skinned, that's a vapor barrier. All the insulation is on the exterior of the building, none in the actual walls. In this case, the walls on this one were steel stud on the interior. So no insulation interfere with electrical or plumbing or anything else. And we use green girt clips to hold, which are the fiberglass angles in there to hold the insulation in place. As with that too, you've seen this one here was a total wood construction. We find that the exterior assembly of wood is a lot better on thermal than structural steel studs or steel studs. And we use the zip panels here as a vapor barrier. Everything's sealed. We'll get into a window detail, but so once we have the whole building, you see also the doorway on your bottom left. There's that tarp. So we're doing the air test here during this photo, and just making sure that the whole building is sealed. So part of the challenge for time as contractors is we did not start with any of the cladding here until this building, the roof is on, everything is sealed. So that's why the time is important also, to allow the builder to achieve this point in the construction. And it takes a bit longer, but overall the building is a lot better. On this one too, the earlier one we've seen the green girts and the fiberglass. This one where it was all wood, it's called the long screw method. And so engineering make sure that this would hold our hardy board and siding for the building. And some of this, of course, was the challenge of putting all this strapping on and labor intensive. But at the end of the day too, it's making sure that all your insulation and your vapor barrier, doing the long screw method, it was self-sealing as it went through the vapor barrier back into the wood frame construction. Here we see some of the actual window and the window bucks. We developed the different standards for putting the windows in. We've come up with, after our third job, looking at a plywood window buck, we call it, because you want that window also to be thermally protected. Make sure the insulation is part of that that barrier. So we pre-painted with a liquid air barrier, a Viscon. You could also tape it or blue skin it in different ways. We just felt that the actual air barrier that we use here was compatible with the tapes that we use for the outside of the window and for sealing the inside. That's one of the things, you make sure that your materials are compatible, but also availability. There are more and more products going out there, but still, as contractors, you know the challenge of supply with a lot of materials. We had to be wary of what we were using. So one of the first projects that we used, there was a retrofit total cost was over 10 million. And Prosperity Group did a bit of analysis on that. There were increased costs because of more insulation on the roof. You see, typically it was an R25. We went to an R56 on the roof. Same with the walls above grade. We went to an R38 on the exterior. The walls below grade, we clad the walls below grade to an R43 from an R10. And windows, same thing, thermal performance, air sealing, and the install of the windows is very important, but also the windows themselves. So overall on this building, it was only 4% higher than conventional. As some of the costs in here is not maybe into the time frame, it would be about 3 months longer for this building than a typical, but that's basically because of the time taken for everything to proceed at a proper level, and all the inspections during all the different phases of our details too. Part of that is also the HVAC. It's not here, but part of the cost was the HVAC came in lower on the capital cost, and also there the actual long range is that it will be beneficial for less energy use as we proceed with the building. So I think part of that is working as a team. We found out that a collaborative approach with the clients and architects and designers working together, like I mentioned earlier, it's almost like an IPD. I think that's very important. Understanding the big picture of what you're doing with a passive house project, and sub-trade involvement, making sure that the trades are on board. It's a little different than a typical job. We make them quite aware as their tendering process, but taking care. And it's amazing how many of the trades and our own personnel, once you're on board with a passive house, how proud, we're always as contractors proud of the buildings we do. But just the fact here too that we are doing air testing, we're making sure and hearing the tenants' reports after about the the building itself, and the comfort level and the quality, I think is really important. So in summary, the passive house are all about learning and growing. I think we still on the Canadian side are an emerging market, and as I pointed out, with the tower retrofit that Chris mentioned, and some of the other office areas, I think more and more contractors and designers are getting on board with energy efficiency, especially in the passive house, changing and adapting details. From our past experience, sometimes things work well, other times they don't, but getting back to everyone as a team and kind of doing an analysis after the building is built. The low-income multi-res buildings aren't that different from a standard passive house. Just we pay more attention to the antenna use, the cost, the future of the building, and the timeline. And sequencing is everything. It's about that on a typical construction job, that as we move along, that we understand the building and how we're going to get it done. It's, as you know, it's always about construction schedule. That's what's driven in us lately is, timelines and schedule. I think a little bit has been thrown off now with COVID and supply chain and so on. But making sure that it's a well-run project really helps with the sequencing. And that's the end of my slide program.
Henry, that was fantastic. I have a quick just follow-up question for you directly. You had mentioned that it's a 4%, 4 to 10% basically increase on the costing and the time. Is that on average what you found, that flexibility between 4 and 10% on most projects for passive house? Yeah.
Mostly it's not above that. It really depends on the design. So some of the structural design we're doing lately, we've done the wood, we've done a total precast with Kearns Mancini, and now we're getting into a few of the projects where we're using a delta beam coming out of Quebec. with hollow core, and just seeing that the benefits of that for fast tracking the construction, but also the workability. So there are different methods to do this, but overall the cost is not that greater than the 4 to 10, depending on the detail. It's like anything with the details and what you're finishing up your components with.
Excellent. That insight is very valuable, especially when we go to government and say, listen, for a small increase in price, you have a better product in the end. So that's something that we can definitely take there. I had an interesting question that I'm going to pose, and I think I'm going to table this one to either Chris or Deborah. Question for the panel. What in your option that eventually will lead and well and passive house, will they be combined into one single international standard? Well, I don't know if I like a laughter on that one. That wasn't a joke question. That was actually it's interesting because we have all these standards. And I think from our contractor standpoint can we harmonize this into one and have passive house as the standard?
Can I just take my impression of it, Chris, if you don't mind?
Go ahead.
So in my mind, a lead has accidentally left itself out of the market. It, for the longest time, hasn't been addressing energy, or when it does, not in the holistic way, say, Passivhaus does. You can address the energy points in lead. So you can have a lead building and do Passivhaus, and it will address the energy. But often then the points, say for indoor air quality, requires you to over ventilate, and Passivhaus won't want you to over ventilate. So there's some conflicts there. And I think because we're saying that Passivhaus is not that much of a premium, you can get potentially a better building for not a whole lot extra effort or cost, and that it has the longevity that maybe that lead doesn't have. But they can be cohesive. It's just whether you want to do 2 certificates or 1. And which one do you think is the most profitable or most useful to you? And then the well actually suits very well into Passivhaus, but to run them together. So if you were targeting well, you could use Passivhaus to address many of the well requirements. But I think on the grander scale of where we need to go for the planet and where the governments are going and where banks are going and where all the markets are going, is that zero energy or zero carbon is where we need to be focused. And Passivhaus addresses that as as your fundamental basis of design. Reduce your energy in operation, reduce your energy in materials, reduce, and by the way, that happens to reduce your carbon.
So I do know that we're slightly over time, but I do have a couple of questions just because, well, I have a multitude of questions, but I'm going to reduce it down just to a few. I want, Henry, I'm going to ask you directly on this one. In relation to, you talked about, the integration, talk to your subtrades and all that stuff. How difficult was it to get across to your subtrades to get them to buy in on the whole Passivhaus experience and the level of detail that is afforded a Passivhaus?
I think at first everyone was skeptical and say, how is this going to affect me? I'm going to take a lot more time and effort. My labor is going to go up. It was surprising with the trades, mainly mechanical, electrical, on the penetrations and so on, that if you work together, and if for whatever reason you have to put an extra hole in for the exterior or in some of the envelope itself, just letting everybody know, letting the super know or letting the foreman know, saying, let's work on this together and seal it properly. Overall, so some of the buildings I showed all the exterior insulation, it made it easier for the trades to run their either conduit or BX or electrical wiring. Same with the plumber. It's always about, you're putting insulation in, and you got all the trades working through it. Then you got your vapor barrier, and the penetration through that. Here, our vapor barrier was on the exterior, and with the insulation outside of that, worked very well. The trades was surprisingly, once they have done one, they're eager to do more, realizing not only the importance about energy efficiency, but the cooperation that you have. It helps a little bit sometimes when you're a construction manager and working with a client. It's not just an open tendering process where sometimes you might not know electrical or mechanical or the other major trades, drywall, that you're actually who's bidding you. This way it's a bit more controlled, and people who have an interest in energy efficiency. I think it's got to come from the top down. It did for us. We made that plunge saying this is what we're going to do. And there are other subcontractors now who have done a couple and saying this is really an advantage for us working collaborative on a project. A great working environment.
Fantastic. So I know that, again, we're way over time, but I do have, I guess, one question. I'm going to pose it to Chris, kind of just to close off the session. And we know that, you know, through government policy, you've indicated at the beginning of your talk that, you know, there's a movement toward net zero and the governments are going that way. But how can we build more capacity within the industry, especially on the value of high performance building standards? And what do we have to do to get governments, funders, and owners to change their procurement policies to allow for more passive house teams to be selected?
Well, you know, I certainly have heard from you and others that procurement is really important. So you're going to be giving me a briefing on procurement issues. And as I wander around the halls of municipal government, provincial governments, and the federal government, we'll be reinforcing the messaging, because we have to get procurement right. We hear this from our own members, that it's not it's not in a good place right now to facilitate net zero type buildings. So that's you know, that's absolutely critical, that we address some of the real concerns that your members have and our members have about government procurement. So
I think Chris needs to have a stern conversation with his internet provider now. So I'm going to give Deborah the last word on this one and ask a very simple yet complex question all at the same time. When it comes to, oh, you're back. Okay. Yes, maybe. No.
Doors that I can knock.
We're getting broken telephone here. So Deborah, just out of curiosity, but from once the passive house is done, what is the energy savings result afterward? Because again, if I'm going to convince the government or owners to go to the passive house route, what are your cost savings in regards to the energy savings at the end of the day? And the last question on that one is, does it increase your resaleability for the buildings? Does it, like, you know, is it the amount that you put in, do you get that and plus out? Oh, I'm not hearing Deborah. Deborah, I believe you're on mute. I still cannot hear you. I love technical difficulties. Can someone who's housing this help? You let Deborah unmute. All right, Chris. So we did hear broken telephone from you as soon as your internet kind of broke out, but obviously we'll be having a follow-up conversation on the procurement side of things, because it is you know, incredibly important.
Yeah, it is central to that. You know, I'm not sure exactly what Deb was going to say. We do hear from building owners that the investment in moving to a passive house standard more than pays for itself. This is why Toronto Community Housing, for example, has picked Retrofit for its retrofit standard, because it will save it hundreds of thousands of dollars in natural gas alone every single month, which it can reinvest into building more affordable housing. So it certainly makes sense. When we talk to real estate agents across the country, they're asking us about passive house. How do they resell homes, condominiums, etc., that are now coming on the market or up for resale? There is a premium, a cost premium there. Some of the developers that I've talked to talk about a premium they get for passive house. But at the end of the day, you know, I think it makes perfect sense that if you're paying 90% less, if energy costs are 90% less in your building, that there's some long-term savings there for you. And I will say that's borne out even under construction. We look at the state of Pennsylvania, not necessarily known for leadership in carbon neutrality, but their social housing finance arm has done a significant study. They have given bonus points to organizations that bring forward passive house projects for affordable housing. First year they introduced this program. Passive house housing costs, 4 or 5% more. Second year they ran the program, it was about on par with code built buildings. These are MERBs. Third year, 3.5% less than code. So it demonstrates to us, as Henry was telling us, that as everyone gets up to speed with Passive House, it will decrease in energy. Passive House is not just for multi-millionaire homeowners. It's for all of us. And what needs to happen, what governments need to understand, is procurement is key, but learning how to do Passive House, as Henry has said, is not really that difficult. Our trades training course is only 3 days long. Some of the trades training we do right on site, or contractors like Henry will do right on site for trades who are coming to a building and spend 90 minutes understanding the wall assembly. This is not, as we like to say in Passive House world, this is not rocket science. It's building science, but it's not rocket science. And what Passive House Canada will do is amplify your message to government. We'll provide as much education and training as we can to any of your members who want it. We're really here to support this transformation to a new marketplace.
So that's wonderful. And Deborah, thank you for, she's putting her input into the chat. Seeing as how her mic isn't working, she's got the workaround over here. So she's technologically savvy, even though she's going to have a stern conversation with her internet provider. So with that being said, I do want to take this opportunity to thank you all, the panelists. It's been exhilarating, and I think this may spur into more conversation. Chris, I welcome our procurement conversation. I think it's necessary to do so. Deborah, your insight on the architectural side was fantastic. And Henry, thank you very much for giving our contractors a walkthrough and breaking it down into simple terminology that we can all understand, especially from the OGCA standpoint. And thank you to Passive House Canada as a whole for putting on this presentation for us. I'm sure that if any of our participants have any further questions, address them to either OGCA or to Passive House directly, and we'll be sure to have all those answered for you. And again, if there's more appetite or demand for more information about this, I'm sure that I can twist Henry, Deborah, and Chris's arm into coming back on yet another webinar for us. So one and all, thank you very much. Stay safe. I believe it's stay positive, test negative. All right. Thank you, everyone. Be well.
Thanks, Bye-bye.
Bye.
Take care, everyone. Thank you.